Hey guys, this is Miss Vasenko. We are continuing our 5.4 notes and doing some more Pythagorean theorem applications. So, state if each triangle is obtuse, right, or acute. To figure this out, you need to use the Pythagorean, well, not the Pythagorean theorem, but you need to do your two smallest sides. So 22.4 squared plus 12.7 squared. And I'm going to put a box in between these to show that, I either need to put a less than sign, a greater than sign, or an equal to sign to tell if it's obtuse, right, or acute. So 22.4 is 501.76. 12.7 is 161.24, and 28 is 28 squared is 784. If I add those two together on the left-hand side, I get 663, and 663 is less than 784, which means that this is an obtuse triangle. You're going to do this for every single one here. So 1, 2, and 4 you've seen before. You saw this on your notes on Friday. So your two shortest sides, 20 squared plus 15 squared. Then we're trying to decide if it's greater than, equal to, or less than 25 squared. 20 squared is 400, 15 squared is 225, and 25 squared is 625. 400 plus 225 is 625, and 625 is equal to 625. So this is a right triangle. Now 3 is something that you guys haven't seen before. So you have this square root of 231. We know that 9 is potentially the smallest side. But what about the square root of 231? You need to figure out where that lies within your other two sides. So the square root of 231 would be like 15 point something. So obviously these two here are your two shortest sides. So we're going to set it up as the square root of 231 squared, plus 9 squared is equal to, less than, or greater than 16 squared. Now think back to maybe Algebra 2 if you guys, or Algebra 1 if you guys have taken either of those. If we have the square root of 3 squared, that means that we have the square root of 3 times the square root of 3. We also have the square root of 3 times 3. This 3 times 3 is 9, and the square root of 9 is 3. So look at the first thing that we do versus the answer. The answer is just whatever number is underneath that radical. So for number 3, if we have the square root of 231 squared, we would just get 231 as our answer there. 9 squared is 81, and then 16 squared is 256. If I add up 231 plus 81, I get 312. And because 312 is greater than 256, my two sides are greater than C, this would be an acute triangle. So we are going to be incorporating our or square root symbols, radicals, a little bit more here, just so you can apply those things that you know. So then for number 4, we have 9 squared plus 12 squared is less than, equal to, or greater than 17 squared. 9 squared is 81, 12 squared is 144, and then 17 squared is 289. If I add up 81 and 144, I get 225, and 225 is less than 289, which means that this is an obtuse triangle. Again, if I'm going too fast or if you have any questions, pause it and then go back or email me. Okay, so find the missing side lengths. Again, I'm incorporating some radical numbers here. So what we want to do here is make sure that you guys figure out which sides are your A, B, and C. Your C, or your hypotenuse, is always going to be across from the right angle. Okay, so make sure you remember that. We have A, B, C, A, B, C, A, B, C. It does not matter which one you make A, which one you make B, but just make sure your C is the same, is always across from the right angle. So I have 11 squared plus B squared equals the square root of 266 squared. 11 squared is 121. Square root of 266 squared is just 266, and I will subtract 121 from both sides. So I get B squared equals 145. I'm going to take the square root of both sides. So B equals 12.04 meters. Again, if they give you a unit, you need to use that. The next one, we have 5 squared plus the square root of 119 squared equals C squared. 5 squared is 25. The square root of 119 squared is 119. And then if I add up 25 and 119, I get 144 equals C squared. And then you take the square root of both sides and get 12 centimeters equals C. For 3, we have 6 squared plus B squared equals the square root of 82 squared. 6 squared is 36. The square root of 82 squared is just 82. Subtract 36 from both sides and you get B squared equals 46. Then you can take the square root of both sides and you get B equals 6.78 centimeters. Again, make sure you're using those units if they give it to you. So a couple more applications here. This is, I wonder why that's not working. Okay. If you have a question like this, okay, and you need to, so this would be what they drew for us, okay? We don't have those extra dotted lines written in. So if you don't have a triangle formed, you need to try and form a triangle. That is why they put in these dotted lines here to create, sorry guys. So when you have a rectangle, you know that rectangles have a 90-degree angle in each corner. So we can go ahead and use the Pythagorean theorem here to find out what that question mark is. So, and rectangles always have this 2 lengths and 2 widths that are exactly the same. So if this side is 85 feet, this side would be 85 feet. If the width is 56 feet, this side would be 56 feet. And now you can use the Pythagorean theorem. So 56 squared plus 85 squared equals C squared. 56 squared is 3,136. 85 squared is 7,225. And then I add those two together, and I get 10,361 equals C squared, and then I'll take the square root of both. So I get 101.79 feet is the length of the pipe. Now, a lot of these questions are going to have 2 parts to them. You always need to read through the question. This is asking about how many feet of water pipe will Eva need. So we know that the pipe that we just found is 101.79. The width is 56 feet, and the length is 85 feet. If I add those 3 together, I get 242.79. Now it says about how many feet, so I'm going to round that up to 243, because if you've ever been shopping for building supplies or anything like that, they are not going to give you 242.79 feet of pipe. They're going to ask you to round up, and you're going to have to make the cuts. Okay, if the legs of an isosceles right triangle are 6 units long, find the length of the hypotenuse. Okay, isosceles means you have two legs that are exactly the same, and then we are trying to find the hypotenuse. If you didn't know what isosceles means, it tells you that the legs are 6 units long, which means both of the legs are 6 units, and the hypotenuse is always across from the right angle. So we use Pythagorean theorem, 6 squared plus 6 squared equals c squared. 6 squared is 36, and if I add 36 and 36 together, I get 72, and then I need to take the square root of both sides. So square root of 72 is 8.94 is what C equals. The base of a 15-foot ladder is 5 feet away from the wall. How high from the floor is the top of the ladder? Okay. I see a lot of you drawing this picture like this, and then you putting 15 over here. The height of the ladder is 15 feet. The ladder is here. That means this needs to be 15 feet. The wall is going to be shorter than that. And then you put it 5 feet away from the wall. So we're trying to find this over here. So x squared plus 5 squared equals 15 squared. 5 squared is 25, 15 squared is 225. You'll subtract 25 from both sides, you get x squared equals 200. And then square root both sides and you get x equals 14.14 feet. You cannot have the same height wall as you do ladder, because then you'd have to have the ladder straight up and down. There's no way you can walk up a ladder unless it's like attached by something to what you're trying to get onto. Like if you're trying to get onto the roof, you have to have an angle to the ladder. Otherwise, you're going to fall off the ladder. A 48-inch wide screen television means that the measure along the diagonal is 48 inches. So this is 48 inches here. If the screen is a square, what are the dimensions of the length and the width? Okay, if it's a square, it means all of the sides are the same length. So we're going to use x and x here, and then we are going to plug it into the Pythagorean theorem to find out what x is. Now there is an imaginary 1 in front of my x squareds here. So I'm going to combine those two. 1x squared plus 1x squared makes 2x squared. 48 squared is 2,304. Now I'm sure all of you are asking, well, why didn't she add the 2's together to make a 4 here? You do not add the exponents when you are doing these type of problems. You are just adding the constant in front of the variable. First I'm going to divide by 2, and I get x squared equals 1,152. And then I'm going to take the square root of both sides, and I get x equals 33.94. So the length and the width are 33.94 inches. Make sure you put a unit there. Okay, going on to the back, these problems are a little bit trickier, but you know how to do every single thing here. It's just putting it together in one big problem that trips you guys up. Okay, so 5 in the figure below, AC is 3, and I'm going to fill those in. DB is 4, and AB, the whole entire thing here, is 14. What is the length of AE? So I'm going to put an X there. Okay, now first of all, are these triangles congruent? The answer is no. They do not have congruent sides. They only have one angle that is congruent. But we learned about similar triangles. These two triangles could potentially be similar. Looking at the two triangles, I have my right angle that's already congruent. For two triangles to be similar, I must have two angles that are congruent. I could say that these two angles are congruent because of the vertical angle theorem. And now that means that triangle AEC is similar to triangle BED because of that angle-angle similarity postulate. Okay, now I know they're similar, so I'm going to set up a proportion to find my missing length. But I need to first figure out what is this right here. The whole entire thing is 14. One piece is x, so that means that this piece here is, I'm going to take 14 and I'm going to subtract x from it. Okay, so then to do the problem, so I'm going to do the small triangle to the large one. I'm going to start with my AC and my BD side. So AC is 3, BD is 4. Then I'm going to do my AE side. So AE is x, BE is 14 minus x. And then you'll go ahead and cross multiply. So I have 4x equals 3 times 14 minus x. You're going to distribute in that 3. 3 times 14 is 42. 3 times x times the negative x is negative 3x. I add 3x to both sides. I get 7x equals 42. And then divide both sides by 7. So x equals 6 or AE equals 6. Okay, find DC in the picture. So just looking at this, okay, there are multiple different triangles that I could draw here. Right now I don't have any triangle. The only way that I can use the Pythagorean theorem, because that's the only thing that I have taught you guys so far to find out, side lengths of triangles. I haven't taught you how to find a side length of parallelograms. We need to draw a line somewhere to create a right triangle. So if I draw a line here, I am looking to find out what DC is. I didn't want to do that. I want that. What DC is here. If I drew in that line there, that red line, would me doing the Pythagorean help find DC? It could if I actually had a value here or here. Right now I don't have any values there, so that line's not going to help me. If I drew a line here, wow, that's really bad. If I drew a line here, that could potentially help me because I could figure out what this is. But then looking at this triangle here, it's not a right triangle now, so I cannot find out what that other missing piece is by using the Pythagorean theorem. What we can do is draw a line, straight across to create a right triangle and a rectangle. Rectangles always have a right angle in the corner. So this side would be 18, this side would be 20. And then I have 29, 20, and then I could figure out what this side is by using the Pythagorean theorem. So x squared plus 20 squared equals 29 squared. 20 squared is 400. 29 squared is 841. And then I'm going to subtract 400 from both sides. And I get x squared equals 441. If I take the square root of both sides, I get x equals 21. So now DC would be 18 plus 21, because I need to add up both those pieces. So DC equals 39. Okay, so this one there is a lot of things going on. Okay, in the figure above, line L is parallel to line M. So I'm going to mark that on my, on here to show that those two lines are parallel. Segment BD is perpendicular to line M. They already drew a right triangle there for me. Okay. And segment AC and segment BD intersect at E. What is the length of segment AC? Okay, so the length of segment AC is this whole entire thing here. Okay, you guys see two triangles. We have this triangle here, and then we also have this triangle here. Okay. Now, we have a right triangle, which means that we can use the Pythagorean theorem on that little one. But we only have my 1 there. I don't have anything here, and I don't have anything here. So I can't do the Pythagorean theorem yet. What about the other triangle? Could I prove that that triangle is a right triangle? The answer would be yes, because if BD is perpendicular to line M, it's also perpendicular to line L. We learned that theorem last semester. You could also say that angle B and angle D are alternate interior angles, and because those two lines are parallel, those two angles would also be congruent. So now I have two right triangles. The only one that I could figure out the Pythagorean theorem for would be the big one, because I have my 2 legs there. So let's do that first. So 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. Then if I add that together, I get 169. If I take the square root of both sides, I get c equals 13. So that means that c, this part here, is, why is that not letting me do it? That part there is 13, okay? So now I have to figure out what this little piece is in order to find my whole yellow line there, AC, okay? Because I know that these two are right triangles, the only way that I could do this is to use similar triangles, okay? So this is much like number 5. And I have 2 vertical angles here that prove that these 2 triangles are similar to each other. So triangle ADE, sorry. All right, now that the dogs are done barking, triangle ADE is similar to triangle CBE. So then I can use my proportions to figure out what that missing piece will be. Okay, sorry about that, guys. So for the small triangle, they give me 1, and for the large triangle, the corresponding side would be 5. For the small triangle, the hypotenuse is my x, and then for the large triangle, the hypotenuse is 13. So cross multiply, 5 times x is 5x, 1 times 13 is 13. Divide both sides by 5, x equals 2.6. We know that AC is the AE portion plus the EC portion. So AC would be 13 plus 2.6, and we get AC equals 15.6. Okay, we're not going to do all the last 2 problems, 3 and 4 on your notes. We're going to save those for Friday, but do you remember how to find slope? Slope is y2 minus y1 over x2 minus x1. So for this one, we have 19 minus a negative 4 over negative 19 minus a negative 5. When you have a double negative, it changes to a positive. So we have 19 plus 4 over negative 19 plus 5. So the slope of the first 2 points would be 23 over negative 14. And you can just leave it just like that. For number 2, if you're looking at this picture, we read from left to right, okay? So this line is falling, which means that it is a negative slope. So I go down 1, and then I go to the right 1, 2, 3, 4, 5, 6. So the slope of that line is negative 1 over 6. We are going to do these 2 problems on Monday before we take the mini test. If you have any questions, as usual, email me or get signed up for SRT. Have a great day, guys. Thanks.